A logarithm is a number. So if I write log a of b, this is a symbol for a number. So you read this as logarithm a of b. And it means if you have a, what should you raise it to power of to get b? So what should I put here? This is a symbol for that number. So for example, if I have 2, what should I raise it to get 8, for example? Then I must put 3 here. So I have that the 2 logarithm of 8 is equal to 3. So you read this symbol as the 2 logarithm of 8, meaning that what should I raise 2 to the power of to get 8? And you should raise to the power of 3. In the same way, what is the 10 logarithm of 100? So what should I raise the 10 to the power of to get 100? Yeah, you must raise it to the power of 2. So this is equal to 2. And when you have the 10 logarithm, because it's so common, so often you just write it as log, you don't write 10. So instead of writing this symbol, you can have by convention also write this, it means the same thing. So if it doesn't say anything here, you mean 10 log. And for example, what is the 5 logarithm of 0.2? So what should you raise 5 to the power of to get 0.2? Yeah, you must raise it to the power of -1. Since 5 raised to the power of -1 is equal to 1 over 5 raised to 1. And this is 1/5. And 1/5 is 0.2. There are some general and interesting special cases. For example, what is the logarithm, a logarithm of 1? So if I have a 1 here, what is this? So what should I raise a to the power of to get 1? Yeah, you should raise it to the power of 0. So this is equal to 0. So it doesn't matter what a is, as long as it's not equal to 0. Because 0 raised to the power of 0 is not 1, it's undefined. But other than that, you can put any number and this will work. So the a logarithm of 1 is 0. And what is the a logarithm of a itself? So what should I raise a to the power of to get a? So what should I put here? Yeah, you should put 1. So this is equal to 1. So we have that a logarithm of b. That's the number you should put here. So this is satisfied. So we have, per definition, we have that a raised to the log a of b. So a raised to the a logarithm of b, that's equal to b. Per definition, because per definition this is the number I should put here to make this work. And now I have put it here. So a raised to the log a of b is equal to b. This is just rewritten, the definition rewritten. Then we also have some rules for logarithms. For example, the first one, if I have log a x multiplied by y. So what is the a logarithm of a product of two numbers? That's just the sum of the logarithms. So this is a rule for logarithms. So the log of a product, then you just take the logarithm of each number and add them. All these rules we will show now can be proven, but we won't do it here now. So let's take an example. For example, what is the free logarithm of 3 raised to the power of 4 times 3 raised to the power of 5? Okay, let's first calculate this without using the rule here. Now we can just combine these two. So this is 3 logarithm of 3 raised to the power of 9. So what should I raise 3 to the power of to get 3 raised to the power of 9? That of course should be 9. Okay, so on one hand I have this equal to 9. Let me now use the rule. So instead of calculating this directly, I will use this rule here. And the rule says that I can take the logarithm of the factors individually and add them. Okay, so what's this? The free logarithm of 3 raised to the power of 4. This is equal to 4. And what should I raise 3 to the power of to get this? Yeah, of course, 5. So this is equal to 9. So you see, if I either do it directly, we get 9, or we use the rule here, we get 9. So this at least gives some confidence in the rule. Another rule, instead of a product, we can also have division, or the quotient. So if I have two numbers, x divided by y. So if I have a division here instead of product, then the rule is the same, but I will have a minus sign in between instead. So for example, what is the 10 logarithm of this? So now I haven't written anything here, but then it means per convention that it's a 10 logarithm. Yeah, this number here is of course 10. So the 10 logarithm of 10, that's equal to 1. So you can see directly this must be equal to 1. But let's also use this rule to see that also gives the correct answer. So this rule says that we should take this one, the 10 logarithm of 1000, and take minus the 10 logarithm of 100. And this, what's that equal to? What should you raise 10 to the power of to get 1000? Yeah, 3. And what should you raise 10 to the power of to get 100? 2. So this is equal to 1. So you see it comes out as 1, either if you do it directly or using this rule. So again, that gives us some more confidence in the rule. Another rule for logarithm is if you have log a of number x raised to the power of k. So these are 3 numbers here. Then the rule says that this number k here I can just move down and put it in front. And also put the multiplication sign. So this is a rule for logarithms. So if I have a power here, I can move it down. So this can also of course be proven, but we won't do it here. So let's take an example. So what is the 2 logarithm of 3 raised to the power of 4? Yeah, according to this rule, this is equal to 4 multiplied by 2 logarithm of 3. So the 4 have moved in front and you have multiplied it. Okay, then of course one can ask, what is this? What should I raise 2 to the power of to get 3? To calculate this, then of course we want to find what should I raise 2 to the power of to get 3. You see, if I put 1 here, I'll get 2. It's too small. If I put 2 here, then I get 4. It's too big. So it must be a number here between 1 and 2. 1 point something. But doing this for hand is not so simple. I could of course try. I could first try 1.5 and see if it's too small or too big. Then I could try either higher or lower and then continue in this fashion until I've found as many decimals as I like. But it's easier to just do it with a calculator. But the problem is that the calculator often gives you log 10 as an option, or also sometimes log e. And here is the e, the Euler number. But we will not talk so much about this here now. But when you see it on the calculator, it's also often written as shorthand log n, ln instead of log e. But we'll not talk about this now. We'll come back to that later. But this, so on the calculator you have a button that's written log. But this is log 2. So how can we figure this out now? Yeah, then we can use the third rule, or the fourth rule of logarithm. And that gives us a rule for changing the logarithm here. So you have log b of x. Then the rule is log a of x divided by log a of b. So here's another rule. That's the third rule. So if I take logarithm b logarithm of a number, then I can change it to a logarithm. But then I have to use this formula. So let's say now that I want to calculate this one. Okay, so then we can use this formula. So you have 2 logarithm of 3. And now I want to change it to the 10 logarithm, because then I can use a calculator. Here I can choose any number here. Not 0, but or 1, that's trivial cases. So let's choose 10 here. And what is x? It's 3. And here we also have 10 logarithm. And b, what's that? That's that number, that's 2. And here we didn't have to write 10. We can also just write this log 3 log 2, since that means 10 logarithm. So you see that 2 logarithm of 3 can be calculated as 10 logarithm of 3 divided by 10 logarithm of 2. I should have written 2 here. Okay, so if you do this on the calculator, what will we get then? To 2 decimals we will get 1.58. But there are infinitely many decimals here. So if I want to find out what should I raise 2 to the power of to get 3, so what should I put here? Then I should put 1.58, at least to 2 decimals accuracy. So now we can continue here. So this is equal to 4 times 1.58. Not exactly, but if you estimate the 2 decimals. So this is equal to 6.32. But here it's not correct to do it like this. You shouldn't round off in the middle calculation. So it's better here to calculate using this here. Here are infinitely many decimals. We shouldn't round off here really. So if I do this instead like this, so I write log 3 divided by log 2 from down here. And then now I plug it in this to the calculator. I will actually get 6.33 to 2 decimals. So we got on 6.42 if I round it off in the middle of the calculation. So you should do it as a last step. You should put it into the calculator, otherwise you can get some decimals wrong. So if you plug this into the calculator, you get the more correct answer, 6.33. Okay, so the answer is, what should I raise 2 to the power of to get this 3 raised to the power 4? And this, of course, this is 81, if you'd like to write it as 81. So what should I raise 2 to the power to get 81? You should raise to the power of 6.33, at least with 2 decimals accuracy. So now I have shown how you can use these final 2 rules. So the final rule here is a rule for changing bases. Go from B to any other A. So let us take an example how we can use logarithms to calculate things. So let's say we have a bacteria. So let's say that we start with 1 bacteria. So we start with 1 bacteria. And let's say that they double each hour. So after 1 hour there are 2. After 2 hours there are 4. And so on. So that each hour they double. Then the number of bacteria after t hours should be given by this formula. So after t hours you have 2 raised to the power of t. So after 1 hour we have 2. After 2 hours 4, and so on. So this we start at t equals to 0. This is t equals to 1. T equals to 2 in the units of hours. So this is how many we have. Now we can ask ourselves, for example, how long does it take before this becomes 1 billion bacteria? So 10 raised to the power of 9. So how many hours? Yeah, we can use a logarithm for that, for example. Now, if you are seeking a number t that makes both of these sides equal. So let's assume that we have found this t that make them both equal. Then we can use the logarithm on both sides. So let's take a 10 logarithm on both sides of the equation. Since now we assume that t is the solution to this equation, just say that we have found this number t. So now these both sides are equal. These 2 sides are equal. So then if you take a logarithm on both sides, they are still equal, since we assume these are equal. Okay, so we'll have this we want to solve instead. And now we can use the rule calculation. We can bring down the t here, since that was one of the rules for logarithms. So this is log 2. Okay, so this is the first step we can do. So now we want to find out what the t is. So you just have to divide both sides by log 2. So you can calculate this, we know how long time it will take. But first of all, this is simple to calculate, because he says the 10 logarithm of 10 to the power of 9. So what should I raise 10 to get 10 to the power of 9? Yeah, of course, 9. But log 2, so what is the 10 logarithm of 2? But then we can just plug this into the calculator. So what will that give us? Then this will give us roughly 30 hours. So after 30 hours, we will have 1 billion of bacteria. So this is a concrete example how you can use a logarithm to solve equations involving often exponents.